In the previous video, we saw about probability. Now, if we are completely understood about probability, this will be very easy walking down the path with respect to conditional probability. So it is very less different. So let us have little comparison with respect to what is probability and what is conditional probability. Okay. So conditional probability is finding the probability of event given the other events occur. Okay. So I want to check whether an event will occur, but basically no. Events which are going to occur other than the other events. Okay. So it is like one of the events occurring. So basically, with respect to formula, you can see probability of B divided by A is B or A over here will be like B insertion intersection A. Okay, not insertion, intersection. So probability of B intersection A or A intersection B, both are the same, divided by probability of A. Okay, so when you divide this, you will get probability of B divided by. So basically, we are trying to find probability of an event based on another events. Okay, so here basically when you don't have the probability of B, okay, so you don't have the value of probability of B. So based on probability of A, you can find it out. Okay, so that is conditional probability. And also a simplest way would be something like if you have only two cases, probably heads and tails. Okay, so you have only two outcomes, whereas you know probability of true getting a head, not true, sorry, getting a head. Okay, so that is 0.5. So probability of getting tails, which is the only other condition. So at that situation, 0.5 or 50%. So if you just subtract 1 minus 0.5, or you can just subtract 100% minus 50%, would be giving another 50%. That is the remaining one. Okay. So whereas you can have a dice, okay, 1 by 6, right, for a probability of any one of the numbers occurring, right. So if in that scenario, if you know 5 probabilities and you want to know one which is missing, so then you can see. Else again with respect to those and those conditions, will not be looking at conditional probability. Rather, we'll be seeing probability of B by A. So basically, event that may occur or may not occur. Okay, B. A, which is event which is already occurred and we know it. Okay, the value which we already know. So we are finding probability of B with respect to probability of A. So that is what we meant on the left hand. So let us see an example. So basically, we'll see two dice thrown simultaneously. Okay. So now two dice are thrown simultaneously. Consider them as again unbiased. So and then sum of the numbers is obtained to be 7. Okay. So when you add up the when you have thrown the rolled the dice, so you will get two values on it. Okay. So what is the probability that you are getting the answer as 7? And there is another question known as like we have already got the sum as 7, and what is the probability of one of them is at least 3. Okay, so there is 3 in one of the dice at least. Okay, so we'll see that. So this is the data set, so you can group them like getting 3. So what is the probability of getting A? Like we have two probabilities over here, splitting it. So probability of A is having at least 3. Okay, so you can see 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, 3 and 6. So same probability with respect to the second die being constant 3 and the first die varying from 1, 2, 3, 4, 5 and 6. Okay, so we are not considering the 3 and 3 over here because it is already covered over here. So this is the nothing but the intersection. Okay, so the intersection we are eliminating. Okay, and the B over here is the event telling that getting the output as 7. Okay, so we already like B is the probability which we already know, so that is nothing but the sum of the two numbers is 6. Okay, so out of this we need to find out how many times, what is the probability of having at least one of them is 3. So here you can see out of 6 it is 2, so it is straightforward answer 2 by 6. But let us compute with respect to the formula to understand this better. So what is probability of A over here? It is 11. So you can see it is like we have 11 combinations where at least 3 is present, and for out of 36. Okay, so it is like 6 of per side, right? So 6 into 6, 2 dice are rolled, so that is divided by 36 outcomes, and probability of B is 6 divided by 36. So next A intersection 2. So again the probability 2 by 3 is with respect to only this what I was telling. Okay, so but now with respect to again with respect to whole data set is something else. Okay, so we'll see that. So what is intersection of A intersection B? So that is 2. Okay, so these are the two ones which are present. So that is the 2 which I was mentioning. Okay, out of 6. Okay, that is intersection. Now what is probability of A intersection B divided A intersection B? So probability is like 2, we already know A intersection B, and total number of outcomes is nothing but 36. So that is 2 by 36. And finally applying the formula, so here you will be having probability of A by B is nothing but probability of A intersection B divided by probability of B, which we already know, and the probability of uh, A intersection B is nothing but 2 by 6, and probability of B is nothing but 6 by 2, so that will be equal to 1 by 3. Okay, so that is what I was mentioning, 2 by 3. Okay, so the probability of having at least one of them as 3 is nothing but 1 out of 3. Okay, so that is what we saw with respect to probability of B. And again, here we are checking with respect to probability of B, which has already occurred, and with another condition of probability of E. So that is what we have done with respect to in this example. So next, we shall consider another example. So over here, in a group of 100 computer buyers, so 40 of them has bought brand 1, okay, and 30 has purchased brand 2, and 20 has purchased brand 1 and brand 2. Okay, so like it can be like either brand 1 or brand 2. Like they have purchased both. Okay, so uh, if a computer buyer randomly chosen who has bought brand 1, so randomly chosen, okay, at who has bought brand 1. So here out of 20, what we are telling is like this is the intersection of this 40 and 30 who have purchased both of them. Okay, so that is what is done. So here choosing who has already bought a brand 1 and what is the probability that he is buying the brand 2 also. Okay, so that is the probability. So straightforward answer with respect to probability of A, so that will be nothing but 40, and if you are finding probability of B, that will be 20 by 100. So 0.4, and also we have the probability of intersection between A and B, so that is nothing but 20. So probability of uh, A intersection B is nothing but 20 by 100, so that is 0.2. And next is deploying the formula which we saw with respect to conditional probability. So A probability of A by B is nothing but A intersection B divided by B probability of B. So that is nothing but 0.2 divided by 0.4. So that is equal to 0.5. So basically at random, if you choose a person who has already purchased brand A, has at least 20% of chance, oh sorry, 50% of chance he has bought with respect to this. So if you are just going with respect to instinct, so here only we can tell 40 has brand 1 and 20 of them has brand 2 also. So that is again directly straightforward, like 50%. So the probability that a person has brought a brand 2 computer, given that he has purchased brand 1 only. Okay, excuse me. So that is 50%. So that is with respect to conditional probability. The next video will be seeing further.